Welcome to our channel. And in the previous session we have seen the polygon clipping algorithm, and now let us have a look on three-dimensional transformation functions. So in our previous sessions we have seen the two-dimensional transformation functions. So those are scaling, translation, rotation, reflection, sharing. So in the two-dimensional transformations we have seen all these 5 transformation techniques, and similarly in the three-dimensional transformations also consists of these 5 transformation techniques. So as we know that scaling is used to change the size or shape of an object. So that means the size or shape may vary. And translation means moving the object from one position to another position. So moving an object. Rotation means rotating an object with a certain angle theta. Rotating with an angle theta. Reflection is nothing but rotation with 180 degrees. 180 degrees. Reflection. It's a mirror image. And sharing is just tilting the object. Tilting the object. So with respect to x-axis or y-axis, if we tilt the object, so let it be, if it is a square, the tilting means it will be like this. So it becomes parallelogram. Just like we are applying the italic in MS Word, similarly the object will just tilt towards the x direction or a y direction. So right, this is the x share, this is a y share. So that is called a sharing. So all these concepts we have seen in two-dimensional transformations. That means two-dimensional means only 2 coordinates will be there. One is x and another one is y. X with respect to so x coordinate and y coordinate. So we need to apply the scaling for xy and then translation for xy, and similarly rotation for xy, reflection for xy, and finally the sharing for xy. So we have also seen some examples solving all these transformation functions, and the meaning is similar to the two-dimensional transformation. So here also the scaling means the changing of size and shape of an object, but here it is a 3D object. Here the completely dealing with 3-dimensional objects. So name itself indicates the 3-dimensional means we will be having x coordinate, y coordinate, and similarly z coordinate. So every object will be having 3 coordinates, x, y, and z. So in the previous sessions, 2-dimensional means only 2 coordinates, x and y. Here it will be x, y, z. So in 2-dimensional this is x and this is y. In 3-dimensional it will be x, y, and z. Depth will be added. So scaling means changing the size or shape of 3-dimensional object. Translation means moving an object. Here it is a 3D object. So moving a 3D object from one position to another position. Rotating with certain angle theta of 3-dimensional object. And reflection, rotation of 3-dimensional object with 180 degrees. Sharing, tilting the object in 3-dimensional space. Now for this we have seen some scaling parameters. Those are with respect to x-axis, with respect to y-axis. Now there will be one more thing, that is with respect to z-axis. Translation, also similarly translation parameters we have seen, that is with respect to x, with respect to y, and now with respect to z-axis. And here rotation, here there will be 3 rotations, that is with respect to x-axis rotation, with respect to y-axis rotation, with respect to z-axis rotation. Reflection is also with respect to xy plane, yz plane, similarly zx plane. Sharing is also with respect to x share, y share, z share. So we need to find out the formula, and so in the two-dimensional object, two-dimensional transformations, first we have derived the formulas for all these scale transformation techniques, and we have represented in a matrix format. So here also, first we need to identify the formula, we have to derive the formula, and then we need to represent that formula in matrix representation. So as the explanation is same, let us directly have a formula for everything. So for scaling, translation, rotation towards x, y and z axis, reflection towards xy plane, reflection in xy plane, yz plane and zx plane, and similarly sharing with respect to x-axis, y-axis and z-axis. So let us have a look on the formulas individually, one by one. So first let us start with the translation. So as we know, in the two-dimensional, translation is moving an object from one position to another object. So in order to move the position of an object from one to another, we require the translation parameters. So with respect to, so in two-dimensional plane, there will be only with respect to x-axis, with respect to y-axis, but here it is a three-dimensional translation. So let us represent it as 3D translation. So here we require the third parameter called tz. So there we have derived a formula that just by adding the tx to x coordinate, we will get the new x coordinate, and similarly for getting a new y coordinate, we need to add the ty to the old y coordinate. In order to get the z also, by adding the tz to the old z coordinate. So formulas are x dash is equal to x plus tx, y dash is equal to y plus ty, z dash is equal to z plus tz. So this is a simple formula. So nothing is changed with respect to two-dimensional and the three-dimensional. Just the third dimension is added. No formula is changed. So by representing in a matrix format, we can write it as x dash, y dash, z dash is equal to tx, ty, tz plus x, y, z. So this is a simple formula. So if we add this one, we will get this formula x, y dash and z dash. So translation is moving from one position to another position. Let us move on to the second one, that is scaling. Three-dimensional scaling. Here also, this scaling is used to change the shape or size of an object, three-dimensional object. So in the two-dimensional transformation, that is in two-dimensional scaling, we require two scaling parameters, that is one with respect to x-axis and one with respect to y-axis. Here we require the third axis, that is z-axis, with respect to z-axis. So it requires three parameters, that is with respect to x-axis, scaling parameter with respect to x-axis, scaling parameter with respect to y-axis, and scaling parameter with respect to z-axis. So for getting the new coordinate, x dash is equal to x into sx, y dash is equal to y into sy, z dash is equal to z into sj. So this is the formula. The formula doesn't change over 2 dimensional to 3 dimension. Here just we are adding the third dimension, that's it. Now let us represent this in matrix representation. So x dash, y dash, z dash is equal to sx 0 0 0 sy 0 0 0 sj into x y z. So if you multiply this s and all parameters, obviously we will get this formulas, because x sx into x plus 0 plus 0, right? So 0 into x 0, sy into y sy, 0 into z 0, so sy, 0 into x 0, 0 into y 0, sz into z sj. So one thing we should carefully notice that we are writing the formula, that means matrix representation based upon the formula. That means first we need to write the formula, and from this formula we need to represent in a matrix. So but not the reverse process. So from the formula we are writing the matrix. So this is the base. So if you write the matrix, if you write the formula, automatically you can write the matrix representation. You need not remember this matrix representation, just remember this formula. So based upon this formula, we should write the matrix for any transformations. So this is all about scaling. Now let us move on to the another transformation function, that is rotation. So next one is 3D rotation. So here in the 3D rotation, there will be rotation towards x-axis, rotation towards y-axis, and rotation towards z-axis. That we call it as x roll, y roll, and z roll. So x roll means rotation with respect to x-axis, y roll means rotation with respect to y-axis, z roll means rotation with respect to z-axis. So here let us have a look on a formula for all these x roll, y roll, and z roll. So coming to the z roll, that means with respect to z-axis, so z dash will be z, and x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta. So this is the formula which we have seen in the 2D rotation itself. So from this we have to represent in a matrix format. So that means x dash, y dash, z dash is equal to x cos theta minus sin theta cos theta 1. Into x, y, z. So if you multiply this x, y, z with this matrix, so x cos theta minus y sin theta plus 0, so x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta plus 0, and z dash is equal to 0 into x 0, 0 into y 0 plus 1 into z z. This one. So this is the formula for Z rod, and for X rod. So X rod means X dash is equal to X and Y dash is equal to Y cos theta minus Z sin theta. Z dash is equal to Y sin theta plus Z cos theta. The same formula which we have written, just we are shifting the x and y to x to y, y to z. So x to y, y to z. So x dash is equal to x, y dash is equal to y cos theta minus z sin theta, z dash is equal to y sin theta plus z cos theta. And if we represent this formula in a matrix representation, we can represent it as x dash, y dash, z dash is equal to, so x is similar, so 0, 0, 1, then cos theta minus sin theta 0, sin theta cos theta 1, 0 into x, y, z. So x dash is equal to, this is 0, this is 1. So if you multiply this matrix with this matrix, we will get the same formula. X dash is equal to 1 into x plus 0 into y plus 0 into z, that is x dash is equal to x, and y dash is equal to cos theta into x. So formula has been changed, so 0, 0 cos theta minus sin theta cos theta. Now let us look at it. So 0 into x cos theta, y into cos theta minus z into sin theta, x into 0, y into sin theta plus z into cos theta. Right. So based upon this formula, we need to write the matrix representation. Now let us write the formula for y rod. So y dash is equal to y, z dash is equal to z cos theta minus x sin theta, x dash is equal to z sin theta plus x cos theta. So this is the formula. Just we are shifting. X will be moved to y, y will be moved to z, and z will be moved to x. Similarly, in the x row, x will be same. So x formula will be moved to y, y formula will be moved to z, and z formula will be moved to x. Now, if you represent this in a matrix representation, x dash, y dash, z dash is equal to, so here y dash is equal to similar, so keep y as same, 0, 1, 0 into x, y, z. So z cos theta minus x sin theta. So here it will be minus sin theta cos theta 0, and here z dash is equal to x dash is equal to, see here, z sin theta so here it will be 0 and 0. Now 0 into 1 into 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 0 we can write x dash is equal to z sin theta plus x cos theta. So here it will be cos theta, here it will be sin theta. So x cos theta plus z sin theta, and here z dash is equal to x sin theta. So minus sin theta here, and here it will be cos theta. So if you multiply this x cos theta plus y sin theta, so plus y into 0 plus z sin theta, that is x dash formula. And similarly y dash is equal to 0 into x plus y plus 0, z dash is equal to minus x sin theta plus 0 into y plus z into cos theta. So be careful while writing the matrix representation, because first we need to write the formula, and from this formula we need to write the matrix representation. So this is all about this rotation, 3D rotation. So if it is a clockwise rotation, just replace theta with minus theta in every formula. In x roll, y roll and z roll, replace the theta with minus theta, so that here cos of minus theta, sin of minus theta, minus sin of minus theta, cos of minus theta. So all we know that cos of minus theta is equal to cos theta, and the sin of minus theta is equal to minus sin theta. So automatically the formula will be changed for clockwise rotation. So by default the rotation will be anti-clockwise. Now let us move on to the next transformation function, that is reflection. Reflection, that is a mirror image. So here we will be having three cases. One is with respect to xy plane, yz plane and zx plane. So reflection in xy plane is x dash, y dash, z dash is equal to, write the formula here, xy plane, so z will be 0 0 minus 1 0 1 0 1 0 0 into x y z. And for yz plane, x dash, y dash, z dash is equal to, here yz plane, so x will be negative, so 0 1 0 0 0 1 into x y z. Similarly zx plane, so z and x, so y will be negative, y formula will be negative, so y dash, x dash, y dash, z dash is equal to, so 0 minus 1 0, so then write down 0 0 1 into x y z. That's it. So this is a simple formula for the reflection. So this is same which we have seen in the two-dimensional reflection. There is no change. So with respect to xy plane, for the z coordinate we will be giving a negative, and if it is yz plane, x coordinate will be giving negative, and zx plane, y coordinate will be giving negative sign. Now let us move on to the next and final transformation function, that is sharing. 3D sharing. So this is also similar to the two-dimensional sharing. So here also, if it is a sharing with respect to z axis, so there will be two parameters, that is shx and shy, because z dash is equal to z, x dash is equal to x plus z into shx, y dash is equal to y plus z into shy. So this is the formula for sharing with respect to z axis. So z will be no change. So similar to our two-dimensional sharing. So there also in x share. So in x share, x will not change. Only the y coordinate will be changed. Here also share with respect to z axis. So z dash is equal to z and x dash is equal to x plus z into x shx. Y dash is equal to y plus z into shy. So this is the formula to find the new coordinates. We need to represent in a matrix format, that is x dash, y dash, z dash is equal to. Now we have to represent in matrix 1 0 shex 0 1 shy 0 0 1 into x y z. So let us multiply and see the formula. X dash is equal to 1 into x plus 0 into y plus z into shx. So perfect. Y dash is equal to 0 into x, y 1 into y plus shy into z. Right. Z dash is equal to 0 into x 0 plus 0 into y 0 plus 1 into z z. Okay. So based upon this formula, we need to represent the matrix format. So first we need to write the formula, then we need to represent in a matrix format. So just remember this formula so that you can easily write the matrix representation. Now similarly with respect to x, share with respect to x. So it is share with respect to x, that is x dash is equal to x. So y dash is equal to y plus x into shy, z dash is equal to z plus x into shj. So here two parameters, sharing parameters with respect to y axis and z axis. Here two parameters with respect to x axis and y axis, because this is z share. This is sharing with respect to the x axis. Now let us write the matrix representation for this formula. X dash, y dash, z dash is equal to, so x dash is equal to x, so it will be 1 0 0 shy 1 0 shz 0 1 into x y z. So let us now multiply this matrix so that we should get the formula. See, x dash is equal to 1 into x plus 0 into y plus 0 into z, that is x dash is equal to x. Y dash is equal to shy into x plus y, shy into x plus y. Z dash is equal to shz into x plus 0 into y plus 1 into z, that is z plus y. Now similarly we need to write the formula and we need to represent the matrix format for sharing with respect to y axis. Share with respect to y axis. So y dash is equal to y, x dash is equal to x plus y into shx, z. Z dash is equal to z plus y into shz. So this is the formula for sharing with respect to y axis. So if we write in a matrix format, x dash, y dash, z dash is equal to 1 shx 0 0 1 0 0 shz 1 into x y z. So let us multiply these two matrices. So 1 into x plus y into shx, x dash is equal to, so this is perfect. Y dash is equal to 0 into x plus y 1 into y plus 0 into z, that is y dash is equal to y. This is correct. Z dash is equal to 0 into x plus shz into y plus 1 into z. So this is correct. So these are the formulae for basic three-dimensional transformations. There is not much change for three-dimensional transformations over two-dimensional transformations. The only change is on the third dimensional, that is z-axis. So the remaining procedure is same. If we want to rotate a triangle, we need to consider the three vertices, and we have to apply the formula for x roll, y roll and z roll. So similarly, if the translation must be done, we need to consider all the three vertices and consider each vertex. So each coordinate. So each coordinate must be translated. So first coordinate, consider the first coordinate, apply the translation, and then find out the new coordinates. Then consider the second coordinate, apply the translation and find the second new coordinate, and then consider the third coordinate and apply the translation, find out the third new coordinate. So the remaining procedure is same, the only difference is the z coordinate. So in two-dimensional plane, that is, we will consider only x and y, whereas in the three-dimensional transformations, we will consider x, y and z. So hope you understood these three-dimensional transformation functions. So once again I am saying that we need to derive the formula. First we need to write the formula, and from this formula only we have to represent in a matrix. So never remember this matrix, just remember this formula so that you can easily represent this formula in a matrix. Let us stop here, and in the next session let us continue with another topic, and hope you understood this 3D transformation functions. Thank you.